In this video, I want to talk again about risk aversion and give you a third and final definition. Remember, all of these definitions are equivalent. So in giving you a third definition, we will talk about another concept, a new concept called certainty equivalent. So imagine that I give you a lottery, say a usual lottery that I've been giving you. So let's say you get £1 with 50% probability, you get £5 with 50% probability. So £1 and £5. And imagine that these are the 2 points of that utility. And now I'm also going to give you the actual utility function. And I've picked a concave utility function. So we know from the second definition that we're dealing with a risk-averse individual. Okay. Now the next question that I want to answer is, what is the certain sum of money that such that such that the individual is indifferent between the sum, the certain sum, and the lottery. And what I would like to do is I'd like to give you this answer. I'd like to give you this answer graphically. So remember our assumption of the expected utility maximizer meant that this utility U1, this utility U2, I said 50% here, 50% here. So the expectation will be right at the midpoint here. So right here is going to be my expected utility. Okay. And I would like that expected utility is also going to represent the utility from this lottery. Okay. And therefore, if this is the level, if you like, of the expected utility from the lottery, and that same level of utility can be gained if I give you this amount for sure. We're going to give this sure amount a special name. We're going to call it a certainty equivalent. Okay, we're going to call that a certainty equivalent. And what you should also notice is that certainty equivalent there is lower than my expected value, which is the midpoint because it's a 50-50 probability there. So the certainty equivalent is the certain sum of money such that would make an individual indifferent between that certain sum and the lottery. Here's another way to look at it. The certainty equivalent is the maximum amount of money that one would be willing to pay to get this lottery. Okay, so you could see it also that way. You could see the certainty equivalent as the maximum amount of money that someone would be willing to pay to get this lottery. If if they can buy this lottery for something less, they would take it. If this lottery is offered for more than their certainty equivalent, they will not take it because they would lose that amount of money. Okay. So, and now with that, we have established our third equivalent definition of risk-averse individual. So a risk-averse individual has a certainty equivalent, which is less than or equal if you have a lottery which is what we call a degenerate lottery, which is doesn't have any uncertainty, or equal to the expected value of any lottery. Note all of these definitions are equivalent. So when the first definition was a risk-averse individual is someone who prefers the expected value of the lottery than the lottery itself. Okay, um, which means that they would not buy a lottery for the expected value, right? They would want a lower price, effectively. So that goes back to this certainty equivalent being lower than the expected value. And finally, what drives this being lower than the expected value is exactly the concavity of the sure money function. And with that, I'll end it at this video, and I'll see you on the next one.